Good morning, friends. Today we will talk about another data structure called stack. Okay. So stack is a linear data structure which follows a particular order in which the operations are performed. The order may be last in first out or first in last out. So it's a normal data structure but have some order. Order means elements will be outputted in particular order. There is either last and first out or first and last out. So last inputted element will be outputted first, or first inputted element will be output at last. Both statements are same. A typical example is plates stacked over one another in a canteen. So you already seen that. Okay, plates are being stacked in the canteen. So normally the last plate that we put on the stack will be taken first, and the first placed plate will be taken only the last. So the typical example of a stack data structure. Okay, basic operations of stack. First operation is called push. Push is a name changed only. It's same as the insert operation of array. Okay, so push is an operation which adds an item into the stack. Stack is full, then it is said to be an overflow condition. So we cannot insert more elements into the stack. So it's another name of insert. But here we will not insert, we will not use the name insert. Instead of that, we will use push. So next function is pop. It's same as delete. It's used to remove the elements from the stack. So it's called pop. Remove an item from the stack. The item are popped in the reversed order in which they are pushed. Already said it's a last and first out. The stack is empty, then it is said to be an underflow condition. So we cannot insert, we cannot remove further. Another very important function is peek. Return the top element of the stack. So currently I inserted some elements in the stack. I want to check the top element. Top element means if I call pop now, which element I will get. That's a peek. In order to check that, it will not return, it will not delete elements. It is just a function to check the current status of the stack. Because we can only access the top element. We cannot access other elements. Only by removing the top element, we will get access to other elements. So peek is used to check the top element. Okay. Another two functions are there. Is empty returns true if stack is empty, else false. Okay. Is full returns true if stack is full, else false. Okay. The time complexity of all these operation will be order of n. So we'll check that. Okay. So these are the operation push, pop, peek, is empty, is full. So these are the 5 operation supported by stack as a data structure. Okay, we will go to the ADT. But ADT you already know it's a mathematical model of a data structure. So stack as a data structure. So it specifies 3 things: domain, then functions, and the axioms. Okay. So domain or data. It's data for storing elements. Any type of data we can store in the stack. There's no condition. It's not an array. So any type of elements we can store. So data for storing the elements. Then there is another pointer called pointer variable is used. It's called a top. It's used to access the elements in the stack. Okay. It's a special variable or a pointer used to access the elements from the stack. Top. So these two things are available in the domain part. In operation, we already see that push function is there. While pushing, we have to pass the item for inserting. Pop, we don't want to pass anything. We just want to call and it will return the value. Okay, we have to write like that. Peek, the same function, it will return the top element. Is empty and is full are two Boolean functions. Check whether stack is empty or stack is full. So this is the ADT, and the axioms is a set of rules for implementing the these functions. For pushing, we have to pass one element. Item should be passed. Popping, it should return the value. Peak should return the value, and isEmpty and isPulls are two Boolean functions. So that rule is the axioms. Okay, now we can implement stack in different ways. First of all, we'll study about stack implementation using array. Okay. So while we are implementing stack, after that, after some times, we will learn stack implementation using linked list also. Okay. So what we are going to do is we are trying to implement a stack using an array. It's not part of the edit. Edit is over, or edit is saying, okay, it's a mathematical model saying that, okay, these are the things we have to do. It's not thinking about the implementation. But in order to get a feel, what we are going now do is we'll try to implement a stack using an array. When we are implementing a stack using array, the first condition, what I said is there is no, we can insert any type of elements in the stack. That's a normal stack. But if you are implementing a stack using array, what's the problem is that as array, we can store only similar type of elements. The stack implemented using array will also have similar type of elements. We can store similar type of elements in the stack. Okay, so in the case of array, the top variable is, as I said already, it's a pointer used to access the stack elements. So here the pointer act as the index of the array. Okay, so you can place the top element in any value. So here in this example, I'm setting the top element as -1. So -1 is the initial element. So what I'm trying to do is I will be inserting the elements in the 0, 1, 2, 3. So stack is an array which will be used to store the stack elements. The size is there. It's used to check the size of the stack. Okay, size of the stack should be this one. Okay, we will see the example of push function. What I'm writing here is a pseudocode. Pseudocode means it's similar to a function, a C programming function or Java programming function, similar. So this type of pseudocode will be used throughout our data structure. What's the advantage is that it's very easy to convert to a program. We can directly convert. We will see the example. Okay, push function. Push function, we already said we have to pass an item. So first we will check if the stack is full using isFull function. Okay. isFull function is called, it will return either true or false. If it's true, then we will say stack is overflow. Otherwise, it's not overflow, we can insert. So how we are going to insert is stack plus top. Stop will be incremented. So initially it is in -1, it will be moved to 0th position and the first item will be inserted there. Okay. If I want to insert more again one more element, I will again call this function push function. Push again next element. So again it will check whether the stack is full. If it is not full, then again top will be incremented, so it will move to the first position and item will be inserted. Like that will go. So what's the time complexity? It will only take one time because there's no loop there. Just a if condition is there. Okay, that's a push function. Next one, pop function. Same. It will return the deleted element. Okay. First we will check whether it is stack is empty or not. Okay, if it is empty, we will say stack underflow. So using the isEmpty function, check that. Next, otherwise we can return the value. How we will return? I will return a stack of top minus. Means currently top is in first position. That element will be popped out and top will be decremented. If I call again, what will happen? Top is in the 0th position. Top will be the element in the 0th position will be removed, will be returned, and top will decrement. So it will be set as -1. So what if we call again? What will it will give? Stack is under because top is initially set as -1. Next function is peak function. It's used to check the top element. I just want to check the top. Same, it's also check whether the stack is empty or not. If it is empty, it's way underflow. Else it will return stack of top. It's not decrementing. It's just returning the top element. If I inserted two elements, top will be in the first position. Okay, so it will the first position like that. Okay. Then isEmpty function is there. It's used to check the stack is empty or not. So we set it top equal to -4 for an empty condition. So it will check if the top is -1. Is -1 return true, else it will return false. Is full is there. Actually, we are inserting elements from 0th position. So size -1 is a top is the full condition. So top equal to size -1, then it will return true. Otherwise, it will return false. So all these functions take only water of one time because there is no loop. Just if conditions are there, we have to call it again and again. And there is a common doubt. Okay, I want to insert 10 elements into the stack. Don't write a for loop inside the push function. Instead of that, we can call the push function again and again. That's the thing. Same like that pop and all other functions. Don't modify the function. That's the main thing of ADT because we have already defined the function should be like this. So we have to follow it. Okay. So we'll see an example. So I want to insert some elements 20, 30, 40, 50. Size of the stack is 3, size equal to 3. So initially top will be in the -1 position. So I want to insert the element. So what I will call the push function. So I want to perform this much operations. I will write like this, modify this push 20, push 30, push 40, 40 is there, and push 50. So I will call the function again. First I am calling push 20. What happens? Top will be incremented by 1. Okay, top will be incremented by 1. It's a code here. First it will check stack is full. It's not full. Full condition is what the full condition top equal to size -1. So size is 2. Size -1 is 2. So top is -1 is not equal. So it will return false. So we can insert the elements. So what we will do, stack of plus plus top. That means top will be incremented by 1, -1 will be incremented by 0, and item will be inserted into the stack. So this will push. So top will be incremented to 0. Next again I am calling push function. Top will be again checked. 0 is compared with 3. 3 -1 is 2. 0 is compared with 2. It's true. Then again I can insert the element. Then this will be 1. Then 1 will be compared with 2. Okay, again it's true condition. I can insert one more element. So it's 2. If I try to insert a push 50, what happens is the stack is full, return stack is overflow. If you cannot insert further. So if I call a pop function again, pop function at this point, what will return? So what the top will be checked. It is -1 or not. Pop is empty. Empty is top equal to -1. It's not -1. It's currently 2. So it's not -1. So what we can do is it will stack of top minus. That is stack of top. Top is currently 2. This stack of 2 will be returned. That is 40. 40 will be returned. And then top will be -2. It will be decremented to 1. If I again try to call push function, it can insert push now 50 again. I can insert it will move to the second. Okay. If I call a peak function now, what happens? If I call peak function, is just not returning. It's returning. It's check will it will just check whether the stack is empty. It's not empty because it's currently in the second position. So return top stack of top. Stack of top means stack of 2. It will return 50. So if I call again pop function, so 50 will be popped out and this value will be decremented to 1. Okay, if I call again peak function, what will happen? It will return the stack of 1 first position value. 30 will be shown, not removed, just shown. It's the difference. I think it's clear. Now that's the data structure stack that implemented using R. Now we'll talk about some applications of stack. Okay, first application of stack is balanced parenthesis. So if the current character is a starting opening bracket, so we want to check whether the parenthesis expression is balanced or not, is in correct order. For that we can use stack. So for that we have an algorithm. What we are doing is the current character is a starting bracket, opening bracket, curly bracket, any type of bracket, opening bracket, and push it into the stack. If the current character is a closing bracket, then pop from the stack. If the popped character is matching with matching starting bracket, then fine, else parenthesis is not balanced. After complete traversal, if there is some starting bracket left in the stack, then it is not balanced. So it's a simple. So we will see an example. So we have a statement like this. Just checking the brackets only. If I check 2 like this, but it's saying that if I see an opening bracket, we have to push that into the stack. We will pushing that to the stack. So stack is there. So we will be pushing the opening bracket. Another stack comes, so we can push that into the stack. Another curly brackets comes, so it will be pushed into the stack. When we see a closing bracket, what we will do is we'll check, we'll remove the opening bracket from the stack. This will be removed, and these two strings will be combined. It's not equal, so you will simply say it's not a parent. It's not a balanced parenthesis. So the bracket is like this. So what happens? So now we have opening bracket only. So this will be compared. Okay, this matching. So this is okay. So one stack is being removed. Next, it will be compared again. This is matching. So another stack will be removed. But the expression has been completely read. But we will check the stack condition. Stack is not empty. That means again it's not balanced parenthesis. An example, in this case, we have the balanced parenthesis. 3 opening brackets are there. We will just push the 3 opening brackets. Okay. Next thing is when I see a closing bracket, we will remove one by one. I remove this one, remove this one, and remove this one. 3 brackets. So expression has been completely read. Stack is empty. It means expression. The expression have a balanced parenthesis. It's a typical example. Okay. Next thing is a very important topic: infix to postfix conversion. What is an infix expression? Okay, we will see that conversion. Before conversion, let's talk about infix and postfix expression. Okay. Infix expression means the expression of the form A operator B. When an operator is in between every pair of operands, it's an infix expression. Postfix expression means expression of the form AP operator. When an operator is followed for every pair of operands, it's a postfix expression. You see an example. Typical example that normally what we use is an infix expression. We write like this: A plus B, where the operator is in between the 2 operands. It's an infix expression. If we write AB plus, is called the postfix expression because the operator is in the last. That is a postfix expression. So why we want to convert? Another important question. So that we will see now. Why to convert? The compiler scans the expression either from left to right or from right to left. So a compiler is doing like this. Consider the below expression a plus b star c plus d. The compiler first scans the expression to evaluate the expression b into c. That we have to do because the precedence of star is higher than plus. So first we compiler have to move to this position and find out b into c, and that should be evaluated. Then again scans the expression a scans the expression to add a to it. This result will be added to a. The result is then added to d after the scan. The repeated scanning makes it very inefficient. So we have to scan it again and again. It is better to convert the expression to a postfix or prefix is also there, that I will say form before evaluation. So what's the main disadvantage of infix expression is we have to consider the precedence order before evaluating, and according to the precedence order it have to be evaluated. But if we convert that to a postfix expression or a prefix expression, we don't want to consider the precedence order. We don't want to consider means it will be all while converting we will be considering that. So after conversion we don't want to consider that. That's advantage. Now what is prefix? Prefix is just opposite of postfix. If you write like this, the operator is in the first position and the operands are after that, then it's called the prefix. So this is the infix and this is the postfix, and this is the last one is the prefix. So what compiler normally use is postfix expression. So we will be converting every expression to a postfix expression before evaluation. So how to convert? So I'll talk about the algorithm first. I want to convert an infix expression to a postfix expression. So what's the statics? Okay, scan the infix expression from left to right. I have to scan from left to right. If the scanned character is an operand, output it. So it should be outputted. Else, we will check if the precedence of the scanned operator is greater than the precedence of the operator in the stack, or the stack is empty, or the stack contains an opening bracket, push it. I will just read that first of all. Next, else pop all operator from the stack which are greater than or equal to in precedence of the scanned operator. After doing that, push the scanned operator to the stack. If you encounter parenthesis while popping, then stop there and push the scanned operator in the stack. Next, if the scanned character is an opening bracket, push it to the stack. If scanned character is a closing bracket, pop the stack and output it until an opening bracket is encountered and discard both parentheses. Okay. Repeat step 2 to 6 until an infix expression is being scanned. So we will repeat this. Finally, pop and output the stack until it is not empty. Print the output. That's a statement we have to. We will see examples. Before doing this example, let's say take a small example. So I want to perform a plus b. We want to convert an expression a plus b. What it will do is we have to scan from left to right. So scanning should be from left to right. If the scanned character is an operand, output it. So it's a is an operand, output it. Then output it. If it is an operator, we will check the status of the stack. So we have another thing called stack also. If stack is empty, that's the statement here. We have some more condition. First condition is stack is empty. Currently stack is empty, and push it. So a plus will be pushed into that stack. Push the stack. Next we will see b. B is an operand, so output. Okay, we have completed completely read the stack. After completely reading the stack, this statement will execute. This 2 to 6 infix expression has been scanned. So that's over now. Pop out, pop and output the stack until it is empty. So we'll remove the stack element and put the output. Then finally we'll print the output. So this will be the corresponding post expression. It's a simple logic. Okay, we will see one more example. So before that, I'll take one more. ABC star C. We'll take this one. So come again. Okay, currently is an operand. Operand is being pushed into the stack. Then plus is there. Stack is empty, so we will push that into the stack. B is there. It is being pushed into the stack. Next, star comes. So if star comes, stack is not empty. So we have to consider other conditions. So first condition is if the precedence, we want to check the precedence of stack. So we know that the precedence of the stack is greater. It is greater if the precedence of the scanned operator, that means star, is greater than the precedence of the operator in the stack. Our condition is this one. So we simply push it. So we will push that into the stack. So stack, we are pushing that to the stack. We can write in both direction. This is this and this is both right. You can write like this also. And following this, both the same. Only difference is where we are pushing, that we have to understand. So star is being pushed. Then next operand comes, is being pushed into the stack. Is outputted. Now completely read it. It will be popped out. So while popping, we have to see the last element. Last element pushed is star. So star is being pushed out, popped out, and plus is being popped out. So this will be the plus. We'll see this example. A star B plus C. Okay. We have firstly we got A. A is being pushed into the stack. Outputted. Star comes, stack is empty, so we should push that in the stack. Next B comes, B is being output. Next is plus comes. So this condition is wrong now. The scanned character is plus, its precedence is less than the operator in the stack. So we have to come to the else part. This is wrong. The statement is wrong. What we have to do, we have to pop all the operator from the stack which are greater than or equal in precedence. Equal precedence is also a problem. Equal in precedence of the scanned operator. For doing that, push the scanned operator into the stack. So we have to remove all the elements from the stack whose precedence is greater than the scanned operator. So star have higher precedence, so it should be removed. Now we'll check, okay, stack is empty. So currently we can insert more. We can simply insert that. Plus is being inserted. Next star C is outputted. Finally it has been completely read. So plus also. So this will be the output. So output of this and the previous one is totally different. AB star C plus and there we see ABC star plus. So totally different. We'll see this one. Another example. So precedence is same now. So there also we have to insert A, plus comes, plus is being pushed, B comes, pushed. Then again plus comes, these two have the same precedence. Then also we have to remove. So this will be plus, this plus will be removed and this plus will be inserted in the stack. Next C will comes and finally we will have the output as this. So we will see some more examples. So I am using a format. So whatever we are reading, that will be written here. Stack values will be written here. Then output value will be written. Okay. We will see this example. So I have the expression A plus B star C plus 2. So firstly we have A. So that can be outputted. Plus comes, stack is empty. We will push that into the stack. Then B, it has been outputted. And star comes, star precedence is higher than plus precedence. So we can simply push that in the stack. star is been pushed. Then C comes, C is been outputted. Next plus comes, so we cannot insert plus. So we will check star. Star have higher precedence, so we will simply remove that. Next again we have to check, not one element. In the previous example we have only one element, but here one more element is there in this. We have to again check plus and plus is there. That's also to be removed because same precedence, that should be also removed. Plus is being removed. Now stack is empty, we just push that plus here. Then D comes, D is being outputted in the stack. And finally we have the plus, so we have the expression ABC star plus D plus. That will be the corresponding expression. Okay. Now we'll see some more examples. So we have the brackets. Okay, that we will discuss now. We'll take one by one. First expression, we'll write. So this is our expression. I want to evaluate this. So this is my expression. So we have an opening bracket. That's still now we have not encountered parenthesis. If opening brackets comes, what we have to do? It has been written here. So if the scanned character is an opening bracket, push it. So we will simply push that in the stack. So we'll write here, and that's it. We'll use this format. Use this. So we have the expression like this. This is our expression, and we want to perform increase the size. Okay, so we have the expression like this. What we have to do? So we have the opening bracket. Opening bracket is there. Push that into the stack. Push that into the stack. So opening bracket, we don't want to check anything. Another opening bracket, we'll just simply push that into the stack. Then we can have the A that will be outputted here. A is there, outputted. Then plus will comes, plus comes, and we have an opening bracket in the stack. This condition we have to. Okay, plus comes and stack contain an opening bracket. So tag means that tag P condition we are only checking. We are not checking the whole thing. The stack top element is opening bracket. Push it. So we will simply push that into the stack. So plus will be there. That opening brackets. Then B comes. It can be outputted. So it is output as AB. Then closing brackets. Closing bracket is there. If closing bracket comes, what we have to do? So we have to follow this rule. If the scanned character is in closing bracket, pop the stack and output it until we encounter an opening bracket, and discard both parentheses. That's the thing that we have to do. So closing bracket comes, we have to pop the elements from the stack. So A, B is there and output it. Then we encounter an opening bracket here. Discard both the brackets. So bracket will be discarded and we will have only one opening bracket here left. Next thing is raised to symbol. It has highest precedence order. Then plus, okay, raised to comes and we have an opening bracket. Already we said if it is we encounter an opening bracket, the stack, we just simply push that. And C comes, C is being outputted. So C is being outputted, AB plus C. C is being outputted. Then minus comes. Minus have less precedence than opening bracket. We will start to remove the elements from the stack. Minus comes and we have an opening bracket. So what we have to do, AB plus C is there. We have to remove one by one. We remove the element. And we encountered an opening bracket. So I'm following this rule. We are popping all the operators from the stack which are greater than or equal precedence of the scanned operator. Push the element. If you encounter a parenthesis while popping, then stop there. We have to stop there and push the scanned operator into the stack. That rule we have to follow. We encountered a bracket here. We can simply push the element in the stack. Again, an opening bracket. Opening bracket comes. We simply want to push. We don't want to check anything. Next, B comes. B is being pushed into the stack. A, B plus C raised to is there. Then D. Then comes star. Star comes and an opening bracket is in the stack. So we have to follow this rule. There is an opening bracket is there. Stack contain opening bracket, push it. So we will simply push that element into the stack. We don't want to check anything. Star, opening bracket minus opening bracket. So like that, push. Then E comes. E have to be pushed into the output. So we will push that into the output. So E is being pushed into the output. Then closing bracket comes. We have to pop it until an opening bracket encountered. So this will be E is there. So star is been removed. So now we have an opening bracket. We will close there. So minus and opening bracket still left in the statement. Then we will have the slash. Slash have higher precedence than minus. So we will simply push that into the stack. Simply push that into the stack. Then F comes. F is been output to the stack. Output to the output. Okay, F is been encountered. Then we have the closing bracket. So we will simply remove that. Closing bracket comes. So we will remove elements till the opening bracket. So that's the answer we will get. The answer will be A B star F slash minus. This will be the corresponding postfix expression. So expressions like this. Okay, we will see some more examples. So another example. So opening bracket A B A plus B raised to C raised to D star E minus F slash. So we will see this example. So opening bracket is there. We will push that in the stack. A comes, output to the stack. Output plus comes. Opening bracket is there in the stack. So we will simply push that plus. B comes. AB is been outputted. Then closing brackets comes. We have to remove the element till the opening bracket. So plus is been simple. Then we have the raised to. Raised to comes. Stack is empty. Simply push that stack. C comes, outputted. Then raised to comes, same precedence. So that means we are forced to remove the element. So this first raised to will be removed. And now we will check again. Stack is empty. So we will put that new raised to there. Next D comes, outputted to the stack. Outputted. Then star comes. Star have the less precedence than raised to. So we have to remove the raised to. Raised to has been removed. Star. Now stack is empty. We will simply push that. E comes. E can be outputted. Then minus. Minus is there. So currently we have the star. So we cannot insert. Star is been removed. And minus is been inserted. Then F comes. F is there. F is been outputted. Slash comes. Slash a higher precedence. So we will insert that slash. Then finally G is there. G is been outputted. Completely read at the string. So now we will just remove the stack element. So this will be the output. AB plus C raised to D star FG slash minus. That's will be the output. Let's see on some examples. So another thing, 300. So this statement we have to convert. So first opening bracket, our stack, 300 outputted plus it will be pushed into the stack, 23 outputted. Closing bracket comes, So we can remove up to the opening bracket 323 plus. Then we have the star, stack is empty, simply push that into the stack. Opening bracket, we will push that in the stack. 43 comes, outputted, minus comes. So currently the stack top is opening bracket, simply push the element. So minus is been pushed. Then 21 comes, 21 is been outputted. Next a closing bracket is there. So we have to remove the element till the opening bracket. So minus will be removed, star is still there. Slash comes, same precedence. So we have to remove the star is been removed, stack is empty, so slash is been inserted. Next an opening brackets comes, simply push that. 84 comes, outputted. Plus comes, opening bracket in the stack top, so simply push plus. 7 comes, 7 is been outputted. Now we will have the closing bracket. If closing bracket comes, we have to remove till the opening bracket. Opening bracket. Now stack is empty. We will completely remove the element. So this will be the okay. Another one. So opening brackets pushed in the stack 4 outputted plus it is been pushed into the stack 8 outputted. So closing bracket comes. So till the opening bracket we will remove. So 4 8 plus is being. Then star comes. Stack is empty. Simply push that into the stack. Then opening bracket comes. So we will push the opening bracket here. Opening bracket is being pushed. Star is there. Okay. 6 is there. Outputted. Minus is there. So currently stack top is opening bracket. Simply push minus into it. Okay, 5 comes, outputted, closing bracket, till opening bracket we will remove. So star remains, remaining things we will remove. 6 5 minus becomes. Then we'll have the slash. Slash is there, same precedence. So we have to remove star and slash is been pushed into the stack. The stack is empty. Okay, next again opening bracket, simply push. Another opening bracket, simply push that into the stack. 3 comes, it's been outputted. Minus comes, stack top is opening bracket, simply push with the stack. 2 comes, outputted, closing bracket, till the opening bracket we will remove. So minus we up to minus we will remove. Still opening bracket and slash is still there. Star comes, opening bracket, simply push there, star. Then again an opening bracket, it is been simply pushed. 2 comes, outputted, plus is there. Plus opening bracket is there, so simply push that. 2 comes, outputted, closing bracket, remove till the opening bracket. So opening bracket is been removed, up to this is been removed. Then star, opening bracket, slash is still there. Another opening bracket comes, so we will remove star also. Then slash is also being removed. Both is being removed, so finally we will have the output. Okay. I think it's clear. Very simple algorithm is very important because this will be asked surely in the examination. Now we will see some more things. Infix to prefix conversion. We already said prefix means operator comes first, then the operands. How to convert to prefix? Sometimes you will be asked like this. So it's very easy. So algorithm is slightly different is there. First we have to reverse the infix expression. That is A plus B star C will become C star B plus C. Just reverse that. Not while reversing, opening brackets becomes closing bracket and closing bracket becomes opening brackets. That's the thing we have to consider. Then we have to perform the postfix expression conversion, obtain the postfix expression of the modified expression. So B star, CB star A plus will be converted to the postfix. Finally, we'll just reverse the postfix expression. Hence, in our example, it become plus A star B C. That's a so simple technique. You see the example. So we have the expression a plus b star c. I want to convert to a prefix expression, not postfix, prefix. First I want to reverse it. I will rewrite it as reversed order, c star b plus a. Next I will perform the postfix conversion. So c comes, it is been outputted, star comes, it is been pushed in the stack, b comes, outputted, plus comes, higher precedence, so star is been removed, plus is stack is empty, plus is been pushed in the stack. A comes, outputted, so completely read it. The string becomes CB star A plus. Now we will reverse that. So it becomes plus A star BC. That's the corresponding expression. We'll see one more example. So here we have brackets. I told you while converting, the opening bracket becomes the closing bracket becomes the opening bracket. Okay. So this expression I want to convert to a prefix. So we have to reverse the order. So this closing bracket becomes an opening bracket. This closing bracket becomes an opening bracket. 2 comes, 2 is been pushed. 2 plus 2. This opening bracket becomes a closing bracket. Star. Then 2 is there, 2 comes, then minus 3, closing bracket, slash 5 minus 6, closing bracket, star, opening bracket, 8 plus 4, closing bracket. So this will be the corresponding converted form. Then we will perform the conversion as before. So we will convert that. After conversion, we will rewrite the order. So order has been rewritten. So star plus 4 8 slash minus 6 5 star minus 3 2 plus 2 2. This will be the corresponding prefix. So all that things is there. Okay. Next thing is evaluation. Okay, I told you compiler will convert the expression to the postfix expression. After conversion, what it will do is it can evaluate that. No need of checking the precedence order because while converting we have already checked that. So what's the algorithm for evaluation? It's very simple algorithm. So while reading the expression we have to read from left to right. Push the element in the stack if it is an operand. So we have to just do the opposite of what we have done still now. When we see an operand, we push that into the stack. And next thing, pop the two operand from the stack if the element is an operator and then evaluate it. We are talking about binary operator only. For unary operator, we have to take like that. What we have to do is, when we see an operand, push that into the stack. When we see an operator, we'll check the operator, whether it is a binary operator, unary operator, or ternary operator. According to that, we will pop the element from the stack and it will be evaluated. After evaluation, it will be pushed back. Push back the result of evaluation. Repeat it till the end of the expression. So that's the thing we have to do. Okay, this process we have to do again and again. Finally, we will get the result in the stack. That will be popped out. See some examples. Okay, I want to evaluate this expression. So first thing, I will convert this expression to the corresponding postfix expression. What I will do is, so I have the expression 300 comes, 300 is being read and it will be pushed into the stack. Okay, so first expression is 300. Next 23 comes, 23 is the second expression. So that is being pushed into the stack. So this is the main thing we have to consider. Second expression is being pushed and currently we will have the second expression. While popping, we will get the second operand first. Okay, so 23 is the second operand. When plus comes, it's a binary operator, so we need two operands. So we will remove 23. 23 will be put it as second operand and 300 will be the first operand. So 300 plus 23 is being performed and we got 323. That result is being pushed into the stack. Next we will get 43. 43 is being pushed into the stack. Then 21 comes. 21 is being pushed into the stack. Then minus comes. I again told you, While removing, the first element will be the second. Okay, 21 will be the second and 43 will be first. 43 minus 20 will be performed. If we are doing in the opposite direction, we will get wrong answer. Okay. This thing we have to be careful. So 43 minus 21 will be 43 minus 21 will be performed, that we will get 22. So 22 is being pushed to the stack. Next we will have the star. So that means we will remove this 22 and 323. So 323 into 22 is being performed. That we will get 7106. 7106. Now we will get 84 is being pushed into the stack. 7 is being pushed into the stack. Then plus comes. So we will remove 7. Then 84. So 84 plus 7 is being performed. So we will get 91. Finally slash comes. So we will remove 91. Then 7106. So 7106 divided by 91 we have to perform. And the result will be 78.06. If we perform in the reverse order, we will get wrong answer. So this thing, important thing, we have to consider this while performing. It's a normal thing because we are been inserting the element like that order. The first element is been inserted first and second element is been inserted after that. So while removing also we have to follow that. And while evaluation also we have to consider that also. It is being performed. So that's a simple example. So you can try the examples or other examples that we have already done. So that's the main thing. This thing also you have to do in the lab. These two things. It's an important thing. So these two are the main characteristics of a main functions of stack. Other applications are also there. Function calling we will use stack, especially in the recursive functions. Let's see an example. So we are calling a factorial function. Factorial. If a less than or equal to 1, less than or equal to 1, return 1, else return in factorial a minus 1. This is a normal factorial. See this. Okay. So take the case of factorial of 5. I want to calculate factorial of 5. 5 is less than or equal to 1. No. So you have to return. We have to again call. So currently we have factorial of 5 is there. Factorial of 5 is there. So factorial of 5 is there. So what we want to do, we will perform. We have to this factorial of 5 have to stop here because this should be evaluated. A into factorial of 4 should be evaluated. So if you want to get the answer, we are performing 5 into factorial of 4 we are calling. So if you want to complete the statement, we have to get the answer of factorial of 4. So what we will do is, we will push this statement, this line, this information in the stack. 5 into factorial of 4 is being stored in the stack. I am going to insert this in a stack. So what factorial of 4 is being called? 4 is less than or equal to 1. It's not true. Again we comes 4 into factorial of 3 we have to perform. So factorial of factorial of 4 statement have to perform what we should perform 4 into factorial of 3 we should perform. So factorial of 3 we have to perform. Now this statement also is not complete because we don't get the answer of factorial of 3. So it will be also pushed into the stack. Why we are using stack we will know now. I am going to call factorial of 3 now. Factorial of 3 is being called. So 3 into factorial of 2 is being called. This is also not complete because we don't get the answer of factorial of 2. We will call factorial of 1. Factorial of 1, factorial of 2 is being called. So 2 into factorial of 1 is being called. So we don't know the value of factorial of 1. So again we will perform factorial of 1. Factorial of 1 is being performed. So factorial of 1, so the a value is 1, so it will return true. So this will return 1. It will return So we have got the answer now. Factorial of 1 is 1. So this value should be passed to whom? Whether it should be passed to factorial of 2 or factorial of 5. It should be passed to factorial of 2. So if we are storing it in a stack, we have been storing like this. First we stored the 5 into factorial of 4, then 4 into factorial of 3 is being stored, then 3 into factorial of 2 is being stored, and 2 into factorial of 1 is being stored. That's available in the stack. These 3 things are available in the stack. So we need the last element that we pushed. So we have to use a stack. So what we will get, if we are storing the elements in the stack, I will call the pop function. It will return factorial of this line will be removed. This line will be given back. So we will get 2 into factorial of 1. Factorial of 1 is 1. So this will be returned as 1. So 2 into 1, 2. So we will get 2. That 2, this 2 should be passed to factorial of 3 because this should be removed. So this will be removed and this value will be there. 3 into 2. 6 comes. So 6 should be passed to factorial of 4. 6 is being passed here. 6 4 is 20. 20 should be passed to factorial of 5. So factorial 20. 5 into 2. 20. We'll get the answer. So we have to use a stack here. So, if we are not using stack, it will not perform. Okay. So that's one of the application. Whenever you are calling a recursive function, you have to we are being using stack. Also, when we are calling a normal function, also it's same. We will be using a stack. There also we will be using this. Another important thing is string reversal. I want to reverse this string. I will push that in the stack and I will pop out. Vertically get the reversed. Backtracking that we will study later. It's a very important application. One of the another application is Tower of Hanoi. I will discuss also later. Okay. So another thing, implementing multiple stack using array. That's not a normal question. We can implement. How we can implement is normally one array, one stack. If we want to implement multiple stack, then we can. If we need to insert 2 stack, one stack can be implemented from first position and another stack can be implemented from the last position. Only thing is that our stack full conditions, stack empty condition will be different. So we can implement n number of stack in a no problem. Okay, that you can try in the lab also. That's how it's stack data structure.